Good day everyone. In this tutorial I'm just going to be covering how to find some very basic descriptive stats on a set of data. So I noticed on the Facebook page that a couple of people were having a little bit of trouble with certain percentiles, so I thought I would just cover the most basic percentiles, or the most commonly used percentiles that we see in stats, being finding the median, the minimum, max, and then finding the first quartile and the third quartile. Now, the general method, there is a generalized method for finding a specific quartile. So one that was mentioned on the Facebook page was like the 80%. However, there are some common methods that are used to find, as I said, the most basic ones, and these are the methods that I know that are definitely utilized within BSP 123. I'm not saying that the other one isn't, however, we'll cover that in a separate video. So the two main differences in terms of how you calculate these things is based upon whether or not the number of elements that you've got within your data set is either even or odd. And there's just one slight difference that you do when you split up to find the first quartile, sorry about this, and the third quartile, and then from that it follows the exact same recipe. So starting off with this data set that we have here, so X is made up of 8 data points, 2, 34, 4, 6, 8, 20, 15, and 5. I just randomly came up with those numbers, so I don't think it matches up with any questions or assessment or anything like that. Okay, so the first step when we're finding these descriptive stats is to rearrange our data into ascending order. You can alternatively do it in descending order, but then you've sort of got to reverse your logic on a lot of things. So I always find it much easier to rearrange into ascending order, and so that's what we've done here. And so to find the first two, which are really nice and easy, is the minimum and the max. So obviously, in the rearranged data, and that's why it's always nice to rearrange the data first, the minimum value is the first value, the maximum value is the last value. So we can easily find that. So the minimum for this data set is 2, and the maximum is 34. Okay, so the next thing that we need to find is the median. Now, the formula that we use in order to calculate the median's position is n plus 1 divided by 2. So in our case, that becomes 8 plus 1 divided by 2, which is 9 divided by 2, which is 4.5. So the median for this data set that we have here lies in the 4.5th position. Now obviously the 4.5th position doesn't exist. We've got the 4th position, we've got the 5th position, but we can't have the 4.5th. So the way that we approximate it is that we take the average of the two. So this should really actually be the median's position. And so therefore, if we want to find the median, it becomes the 4th position, let's put this in brackets, 4th position plus the 5th position divided by 2, which equals, so we go 1, 2, 3, 4, so the 4th position is 6, and the 5th position is 8, so 6 plus 8 divided by 2, which is 14 over 2, which is equal to 7. So the median of this data set is equal to 7. So we've got the min, we've got the max, and we've got the median. Okay, so now when we want to find Q1 and Q3, essentially what we're doing, the median represents 50%, the 50th percentile, or halfway through the data set. The first quartile represents 25% of the data set, or alternatively, you can view it as halfway of the first half. So what I mean by that is, if we take this data set here and we split it into a lower half and an upper half, which is what we're going to do here. So X lower and then X upper. So I've just labeled them XL, XU based upon X lower, so the lower half, XU, X upper half. And as you see, I've got written here, the median of X lower is equal to the first quartile of the original data set. So the way in which we find its position is using that formula exactly the same. So I'm going to call it NL plus 1 divided by 2. Oops, sorry. So NL is the number of elements that are in the lower half. So the number of elements in this data set. And so obviously we see that we have 4 here. So NL is equal to 4. And so therefore the median position, or the Q1, or let's just write it as the Q1 position. So the Q1 position of X is equal to 4 plus 1 divided by 2, which then becomes 5 over 2, which is equal to 2.5. So using the exact same logic as before, we don't have the 2.5th position. We have the second position and we have the third position. So the way that we find the median then is by finding the average. So remember that the median, I meant to say Q1. So the Q1 position, the Q1 of X is equal to the second position plus the third position divided by 2, which equals, so we've got the second is 4 and the, excuse me, the second is 4 and the third is 5. So that becomes 4 plus 5 divided by 2, which is 9 over 2, which is equal to 4.5. So now we've got the first quartile the first quartile of X, and so now what we need to find is the third quartile of X. So as I said before, we apply the exact same logic, except here instead of working on that X lower data set, we're going to be working on the X upper data set. So the X upper data set is, as before, it's already in being rearranged into ascending order. I should have mentioned that before. And so we just use the same logic as before. Median of X upper, which is the third quartile of X, its position is given by, we'll call it N upper divided by 2. And remembering that N upper in this case is 4. So the number of elements in this upper set. And so therefore the Q3 pos of X is equal to N upper plus 1 divided by 2. So we've got 4 plus 1 divided by 2, which is equal to, what am I doing? 5 over 2, which is equal to 2.5. So the 2.5th position. Now I've noticed here, sorry, it is the Q3 position of X, but this is only if we look at this upper half. So at the moment it might just be easier to write this out as the median of XU, which we know is the third quartile. Okay, so this becomes equal to the second position plus the third position divided by 2 of this upper set. So we've got 15 and 20, so that becomes 15 plus 20 divided by 2, which is equal to 35 divided by 2, which is 17.5. Whoops. 17.5. So therefore, we now have all the information that we need for that original data set. So the min was equal to, if we scroll up from before, 2. So we've got 2. Q1 is equal to 7. Q1 is equal to 4.5, sorry. The median is equal to 7. Q3 is equal to 17.5. And lastly, the maximum value is equal to, if I just scroll up, 34, as we see here. Is equal to 34. Okay, so that is the recipe that you use to find the minimum, Q1, median, Q3, and max for a data set that has an even number of elements. As I said, the method that we use when we're dealing with an odd number of data points is exactly the same. The only difference is when it comes to splitting it into the upper and the lower. So I'll get you to that point and then you can do the rest from there. Okay, so starting off here with n is equal to 9. So this is another data set. You'll see it's exactly the same as the data set that we had before. I've just added another value at the end, 10. So we firstly rearrange it into ascending order. The min and the max are very easy to find. So we have this as 2 for the min. The max is 34. And the median, so again, the formula for the median's position is equal to n plus 1 divided by 2. So this is the total number of elements. So we know that's 9 plus 1 divided by 2, excuse me, which becomes 10 divided by 2, which is 5. So we know that the median position lies in the 5th spot of X. So therefore the median is equal to, so going to here, 1, 2, 3, 4, 5. And so if I've done that correctly, we have that the median is equal to 8. Okay, so what we see before, in terms of, as I said, finding Q1 and Q3 is exactly the same. The only difference is how we split up the data. So in the previous example, because we had 8 data points, it was very, very easy to separate it into a lower half, as we see here highlighted, and then into an upper half. Now, what we have here is 9 data points, so we can't do that. We have the same sort of low as what we had before, so we have this 4 and then we have this upper, but we seem to have this value, well, we have this value left over. So the way in which they handle that is that they create the lower to include that middle value, and the upper to include that upper value, to include that middle value, sorry. So when we create the x lower, we include the middle point, as you'll see here. And then when we create the upper half, we also include it. So x upper is equal to here. So from here, you just apply the exact same method that we used before. So we find the median of each of those, and then it corresponds to the Q1 and Q3, depending upon what you're working with. Okay, so I'm just going to leave it there. I'm trying to keep these as short and sweet as I can. If you have any questions whatsoever, either post on the Facebook page, post here, subscribe to the videos if you like them, and yeah, I hope that was informative. Okay.